Okay, so we are dealing with another chapter. So I didn't want to renumber all my chapters since I had already numbered them. Maybe I can do that, but anyway, um, yeah, maybe I'll do it, but don't worry about it right now. So the new second edition of the book has added a few new chapters, as I mentioned. So this one is called Grasping Complexity. We are still in part 2 about approaching the world, and we are looking at human environment systems and how to represent them. So we've been talking about models. Here we'll talk about complexity and the typologies of complexities and how it can be very easy to confuse complexity with complicated. Complex and complicated are not necessarily the same thing. A few additional points that we have to go through. I restate several times throughout this book that our world is uncertain, complex, ambiguous, and dynamic. It's not merely rhetorical, since these four constitute fundamental challenges for us to understand, explain, and improve our sustainability challenges and the world. Although each is essential in its own right, one can be seen as more fundamental than the others because it influences them. So it influences them. I'm here referring to complexity. Whilst a simple system can entail uncertainty or dynamic change, such as a set of dice where the outcome is uncertain, or a pendulum, its dynamic positioning, especially if you go into a double pendulum, but that's not so simple anymore. The uncertainty and dynamic character then escalate with increasing complexity, as going from a simple pendulum to a double pendulum. If you don't know what that means, you go on YouTube and look at some animations. I have covered it in my Earth system model, but let's not worry about it here. Similarly, the potential for ambiguity in our knowledge about a system increases the more complex. I should emphasize differently again. You can see the background has changed again, so because I've moved from one room to another room in the apartment. Yes, I'm living in a 2-bedroom apartment because I have to. The institute will not allow me to live in a 1-bedroom apartment. Complicated story, but that's life. Similarly, the potential for ambiguity in our knowledge about a system increases the more complex it is, since it becomes more and more difficult to ascertain how it works. The underlying reasons for these connections to complexity will soon become apparent when we elaborate on complexity. For now, it's enough to appreciate the particular importance of complexity and that it deserves a chapter of its own, and hence it's been added in the second edition. It is of utmost importance to overcome the common conflation of everyday notions of being complex and complicated, as we'll see in a minute. Whilst these two words sometimes are used synonymously in ordinary language, being complicated denotes intricate chains of cause and effect relations that are difficult but not impossible to fully understand. There are good references you can go and follow up. By the way, I'm called complicated by many people who are also friends, and I think I am complicated because my father was complicated, his father was complicated, and it's fun to watch how you know that you are being complicated and yet you cannot. Anyway, on the other hand, complexity is not a euphemism for ignorance. It's not our lack of understanding that makes something complex, transforming it into something simple when we finally understand it. Again, a wrong emphasis. It's not our lack of understanding that makes something complex or transforming it into something simple when we finally understand it. As introduced in Chapter 7, complexity entails large numbers of elements interacting dynamically and non-linearly, so it is impossible to even fully grasp the system. This chapter is about such complexity. We call it emergent solution. So Earth system is not a convergent system, it's an emergent system, so you find solutions that you didn't expect and couldn't be predicted, and so on. However, it's essential to remember that the human environment system in this book are models constructed. Human environment systems in this book are models constructed to attempt to make sense of an overwhelmingly intricate reality. We can never know if what we try to understand, explain, or improve is complex, only perceive it as such when fitting our observations. So this English of this author from Europe is, maybe he's a non-native speaker, or the editing is quite poor because lots of English problems. So it's not clear whether the system is complex or we perceive it as such when fitting it to observations. I think that's what he means. Moreover, the purpose we have in mind when constructing a human environment system fundamentally determines how we perceive the complexity of that piece of reality. Ashby's analogy of the brain demonstrates this with amusing clarity and simplicity. What does Ashby say? Let's first read that. To the neurophysiologist, the brain as a feltwork of fibers and a soup of enzymes is certainly complex. And then some other text. To a butcher, the brain is simple, for he has to distinguish the brain from only about 30 other meats. So for him, it's just another piece of meat, right? So here is the idea of complex and complicated, and they are not the same. So the complex system demands nonlinearity, and complicated here, can you see the difference here? Wow, maybe this is supposed to be more linearly connected. So here are a few nodes with links to this chain here, which then branches off into different things, whereas here everything seems to be connected to everything else. So you have branches that end here with nodes that end here, but the links are all complicated. I don't know if this helps you, but deal with it. So maybe I'll leave this here and come back. Now let's read this. A complex system invariably consists of a relatively large number of elements. Does this make it clear here? Yes, this has larger numbers than this complicated system. Without such a bulk of parts, their individual behavior can often be formally described in conventional terms. The higher degree of freedom for each element, the higher the degree of freedom for each element, the smaller the number necessary for complexity to arise. So you know what the hand does. It has opposable thumbs. It can pick up things. My brain tells me to do something, says take a sip of tea. I can do that, but the hand is not independent. It can only function when it's attached to the nervous system, digestive system, neural system, and skeletal system, muscular system, and so on. A complex system's elements must interact dynamically. Interactions can transfer something physical or information, but without interaction, a change in one element does not affect the other element. So my brain is full of enzymes, is able to produce electrical signals that are going down the nervous system and making me move my hand, and I know how much force to put based on whether this is a paper cup that can crush or a ceramic cup that needs no such delicate force, right? A complex system's elements must interact dynamically. The interactions can transfer something physical or information, but without interaction, a change in one element does not affect the other elements. Moreover, without the interaction changing dynamically or having the capacity to change dynamically, the transfer between elements is constant and cannot transmit change. So, as I said, the force I put depends on whether I'm holding a crushable plastic or paper or a ceramic cup. The interaction between elements must be fairly rich for a system to be complex. It means that the overall element in the system influences and is influenced by a reasonably large number of other elements. More elements in the system, out of which only some are redundant, the sparser the interaction can be in relative terms for complexity to still arise. So some people don't have a complete hand, they may have few fingers missing, but they can still function. So in that sense, some may be redundant, but obviously when you have all of them, you know that you can do many more things. Let's say you are a baseball pitcher or a cricket bowler and so on, then you may use all fingers, right? The interaction must be non-linear. It means that there are loops of interactions allowing a change in an element to exert influence on that same element after it has been transmitted through other parts of the system and frequently altered during transmission. In a linear system, a change in an element only disperses away from it along branching chains of interacting elements. Okay, so you can see here complicated. I still, it's not still clear whether you can understand complex and complicated from here, but if this system sends information or signal, it can go here, it can go here, and through all the way down here and here, whereas here it goes through many more loops and has many more nodes and links and many more possibilities of things going wild and becoming non-linear. I suppose that's the point, but let's not worry too much about it. So we'll come back and think, look at few more ideas of complexity and grasping complexity. Next up is principle of locality. We mean that the nature of being local in a big system for an element. Okay, so we'll see what that means when we come back. See you in the next podcast.